All right. Welcome back to ECE 382. Kevin Byer here. Got GR coming up Wednesday, Thursday next week. All right. So the first GR, it's about 7 questions. Got a combination of true, false. By 7 questions, I mean 7 main topic areas that then have a few subsections throughout. So true and false, fill in the blank. Few short answer, nothing, nothing crazy. We got assembly to C and C to assembly. So just take a look at, specifically loops, conditionals. How do you do that in C, and how do you do that in assembly? So this is coding. There is just straight assembly, some straight C, but we'll talk about some of the specifics here in a minute. And then that's pretty much it in regards to types of questions. So let's just jump in. So we're at module 9. We're finishing up lesson 17, and then we're moving into the GR. So let me just double check those lessons real quick. Yeah, module 9 switched over to lesson 17, and then the GR is module 18. All right, so 9 modules. We skipped module 2, so now we can cover that. That's not that important to this course. And so really 8 modules, and so let's take a look at those. All right, first module, running code on the Launchpad using Code Composer Studio. That was basic stuff, debugging, stepping through a project. Don't expect a whole lot of questions on that kind of stuff. We're gonna not really deal with testing you on that. Each of the labs really works on making sure you understand that. And then we went into the assembly and the processor, the ARM Cortex-M processor, to talk about a little bit of the architecture. So this is the stuff, that RISC versus CISC kind of idea, little, big Indian kind of stuff. So just take a quick look at some of that stuff again. Your different von Neumann versus Harvard. And what's really important is to remember what we are dealing with in this course. So just kind of understand the architecture as it relates to the Cortex-M processor. All right, the stack. How do we push? How do we pop? What's the process? When do we use the stack? When don't we, need to use the stack? That's that function call, conserving, R 4 through 11. If we use them. If we don't use them, then we don't need to push them. Sometimes we push the link register up on that stack, stuff like that. Addressing modes, that's your indexed, immediate, and PC relative. So take a look at all of that again. All right, and then like I said, there is going to be assembly programming. So that's you need to be able to write and interpret. What is a load, store, post index, pre, or just indexed, that kind of stuff. What's the difference? Move, load, all of that good stuff. How you shift. What's the difference between arithmetic shift and left shift? Logical shift left and logical shift right. So just take a look at those notes. and that will really set you up for success. All right, and then the big thing always comes back to that set, clear, select, toggle. Okay, setting. I'm going to talk about some synonyms here. On, high, 1. Right? So when we set, we're setting something to a high voltage, 3.3 volts. We're turning it on or providing a 1 in that register. Okay? Clearing, off. Low, 0. Okay, that's and then selecting, that allows us to manipulate only specific bits in our ports, in our registers, etc. And then toggle just allows us to turn on and off. Okay, and so remember, setting, we're going to set, we're going to OR with a 1. Clearing, we're going to AND with a 0. Selecting, we're ANDing with a 1. And toggling is EOR, and that's just going to go back and forth. So it's going to either be on or off. And then just look at the, what are the steps for GPIO? So, in that LEDs file, understand that, understand memory access, and then the syntax for those others. So that's pretty much it for assembly. C, a little bit easier, right? Because you're familiar with the, ComSci 210, but don't let that, get you make you think that you don't need to study it. Because remember, this set, clear, select, toggle is unique to what we're doing here. So, when I say port 1 select, that's a register that's part of port 1 memory. So we saw that in the data sheets that we have, all of these different registers, select, select 0, select 1, direction, input, output, and this is all, port 1, and then there's 7 bits, 8 bits, sorry, 3, 2, 1, and 0. Those are those pins. So when we're doing all the set, clear, selecting, toggling in C, we're manipulating these bits, the registers. So remember, for the GPIO, and we'll talk about it a little bit more, but those tables I provided you in that review kind of day where it had assembly review and GPIO review. Take another look at that video, or even just the note taker, and just kind of really understand what those registers are doing. And then just syntax other than that. Again, and set, clear, select, toggle, same concept up here, but just different syntax, right? We're in C now. All right, GPIO, this is where we go into that those steps, initializing ports as input and output. So, select 0, select 1, direction, and if it's an input, then we can start dealing with the register enable and then the output. So remember, if it's an input, we can turn on that pull up or pull down resistor. This just enables it, and then this over here sets it as pull up or down. Okay. Take a look again, positive, negative logic. Again, that assembly review and GPIO review, I did that because I felt there was a little lack of knowledge in that area, so I try to want to bring this in. All right, how do the line sensors work? That charge and then slow discharge. Then we check the value here. Is it a 1 or is it a 0? Read the kind of the description stuff that's going on in that GPIO lab. It talks about how those line sensors work. And then again, those registers, the select 0, select 1, direction. All right, FSMs, I think everyone really got that, but just be able to take something like a enumerated type or FSM, be able to take that and create a graph, or go the other way. So just remember that table is almost a direct copy. So your next state, your inputs, your delay, your current state and output, all of that stuff. It's a direct copy to the C code. All right. Logic analyzer outputs. So just understanding, period, duty cycle, because we are going to have module 9 on this. How do you read that in a logic analyzer? So if I have, something like this, I'm going to have those different cursors, and then up here in the corner it's going to provide you some information, offsets, differences in times, stuff like that. So take a look, look at your pictures, just kind of understand what's going on there. And it says tick timer. What's the difference between load, val, counter, or count, sorry. So remember, load is the basically that n-1 value that we're going to pop up into the counter where we're going to start. Val is the actual current state of counter, so you can think of that as a counter. So when we start at 4, that's what we're going to load into n. We're going to set that first val to 4, then val is going to be 3, 2, 1, 0. Once it's 0, this goes to 1, and then we can do that to interrupt. And then all of these are ticking at 1/48 megahertz, or whatever that is in nanoseconds. So just kind of keep it, just take a look at that again. And it's the most recent module, so it should be fresh in your mind. Well, I will be providing, I call it the GR1 reference guide. So I will provide that for you guys during Module 9, and it will be on the team. But what that's going to be is those data sheets that we were looking at in some of the lessons. So the input, output settings, the different. I'll even have the sys-tick in there. Will be in there, and then also your GPIO information. Sorry, this is kind of similar, but your all those different registers, select, how do you set it as a GPIO, how do you set input, output. So those tables will be in there, and I'm going to provide you those a couple days early so you can kind of get familiar with them, and then that way you have those during those days, because just kind of as an engineer you have data sheets accessible, so we're going to provide those for you guys. So that's pretty much it. What I'm going to do in the next day or so is in the Teams OneNote. So that's where I'm going to take, and I'm going to throw all of the note taker solution. So this is OneNote. So as I'm doing these note takers, I'm taking all these notes. So I'm going to take those note takers and toss them in the OneNote. Additionally, I will take the pre-lab solutions into the team. So you have those, obviously not Module 9 until we're done with that, so that you can expect that probably sometime on Tuesday that will be loaded up in there, but all the other modules I'll load in there. So these two things I think are kind of help you guys out just a little bit. Obviously, without listening to the videos, it's going to be hard to just understand what the notes are saying, but I think this will kind of give you another point of reference so that you can look back and kind of build your confidence. That's all I got. Shoot questions into the team, please, and I'll answer them. Dr. Beck, Dr. York, and Dr. Major Beer will we all watch and look over that team. So just tag the team. We'll go in there. We'll provide any answers to any questions. But I think you guys should be set up for success if you just take a look at your pre-labs and read a few of the things in the actual lab reports, and then take a quick look at your note takers just to refresh some of these ideas that we talked about early on that were kind of a little bit more abstract, and we didn't get to practice as much. But those pre-labs hopefully tested some of that stuff as well. All right, we'll see you soon.